This is the power supply regulator and stuff. I needed to remove 2 screws to be able to pull this up. Oh, we got an op amp, right? And again, voltage regulation, power resistors, fuses, and a lot more power. Transistors in sockets. Don't you just love that? So it's super easy to service. And look at that down here, huh? Low power, high current. This is the main board. Let's see what else we can get out and see if we can get more access to stuff. That was almost impossible to figure this out. Okay, unscrew this, and then to figure out how to bend this and mingle this out. Phew, because I wanted to try and see if you can change the big regulators here. So, okay. They should be in parallel somehow, but I think they got some anode resistors as well. So now we can pull these carefully out of the socket. Come on, baby. See, that is a beautiful, beautiful, beautiful tube. And 2 of those in parallel to generate the high voltage. Isn't that just amazing? Each of those can do like, what, 40, 50 watts? Yeah. Pretty cool. And now I know they actually work because it was tested. And now we can see a little bit more down here with the high voltage regulator. I think I'll try and see how you can access parts. Why do you only mount this mechanical safety on 2 of them, not the other 2? So they can do the bendy. They are isolated. So those 3, they sit in some plastic and stuff, but those are connected directly to metal, so those can be mechanically secured. All right. And what if you need to change one of the bulbs down there? How much do you need to take apart? This wire with, I don't know, 4 or 5 wires in it from the main transformator goes via a shielded cable to this future expansion module for plug-in modules. That means you can generate your own voltages for the future of whatever needs to come. Really, really genius design to prepare for unknown future expansion. So now we're looking at the bottom part again. Let's try and pull up the different PCBs. Wow, look at the track width and, and the solder pad sizes is like 4.5 millimeters, and the track's like 2 to 2.5 millimeter wide. Wow, don't you just love this? You want high yield. You don't want any of your PCBs to fail. Just make the tracks wide. I wonder what all those relays are doing, because it's full of relays. And this is what you see in really old instruments, you see a lot of relays. Don't you just love those hybrid designs? So there's a tube again. What is that? ECC 83, yeah, the dual triode. And 3 transistors and another dual pair transistors. Just fantastic. See if we can just keep pulling. Oh, this was, come on. Wow, a lot of nice medium powered transistors. And some diode and Zener diodes and stuff. So this is some marker 1, marker 2 adjustments. Super beautiful layout. So the last plug-in module. See a little bit higher voltage components, power components, and again the fantastic hybrid design. What kind of tube is that? Ooh, a pentode, a mini pentode. Yeah, it looks a lot like that. Right, so we don't have any more plug-in modules. I am really curious about what is inside this fantastic one. And also, we need to get in here and in the front. Oh, don't you just love this? Oh, this is really nasty high voltage parts, I can guess. But look how they're mounted so they're not gonna fall off when you shake or move or transport this unit, but it's 27 kilos, so I guess you can't really move this product a lot. Alright, so this will be high voltage capacitors. I'm a little bit curious to find out what they can do. I did measure the voltage to 0 before I'm poking around in here. I I cannot loud and clear enough say this and repeat this. You need to check this when you're playing around and stuff like this, okay? Yep, I'm sorry. This is upside down. This is the back panel. Oh, come on. Yeah, here you go. Look at this. So an Endnote Fuse of 0.01 amp. And again, those points really difficult to see, and they will maybe get lost with time and whatnot. But look at this fuse. I don't know if I can make this sharp, but it says, where is it? I thought I saw, yes, here it is. 1/100th of an amp. Duh. Why don't you just write 10 milliamps, you sucker? Anyway, look how they made this just like a bulb there. And there's actually a thin wire between those two solder pads. And it is so thin I am not able to see it. But if you measure here, it is 163 ohms. That thin wire, so it must be insanely thin. It must go from that end to that end. Yeah. Side panel taken off. I guess this piece of aluminium casting is reused for a lot of other products. Look at all the holes for all sorts of screws and stuff. This must be a very, very reusable part. I took out. So this is the spring for the handle. Yep. Very, very smart. And of course the metal is all the way, so you can really, really pull all you want, because this is 27 kilos. Okay, so this thickness is held by 2 screws here, so you should be able to lift it. Actually, I did that. Oopsie daisy. So yeah, this will handle the 27 kilos. Now I am slowly getting in. Remove this piece of aluminium. Was really, really easy. However, the other one here seems to be a little bit challenging. So how do I access this screw? And somebody already jammed to this one, I guess, because you can't really get in here with a screwdriver. So that is going to be a challenge. This is not something I see every day. The main transformator is mounted with 4 screws in the main or the base plate in here, but also 2 screws on the side. They are really going to make sure this is not going anywhere. They don't want it to go. Pretty cool. Now I am all the way in here on the back, and I took out those 2 big capacitors, and look at that. 2 microfarads, 2000 volts. I really like those. They will be good for my projects. And this one was directly connected to the capacitors. So I believe this is a mains to high voltage transformator, but also maybe rectifier diodes or something, because I can't find the rectifier diodes. If they're not in here, where are they? And this is sealed, so we need to open it somehow and see what is in this baby. So imagine those 2 big transformators. Oh, but it's really, really beautiful. Completely sealed. Phew, heavy. Oh, I'm getting more and more in. Soon I can get this PCB out, and I can figure out how to get this plate out. But look, here on each side there's a secret panel, and it sits with double-sided tape. So you need to figure out how to get this out to access those screws. Aha! Now I finally got the side panel off, and look at this solid, and it's really, really heavy. This aluminium casting. This is just tactical grade. Oh man, it is so unbelievable. This is not how you build stuff today. Here we go. The 2 anodes for the voltage regulator. Of course, they got 2 individual resistors from the high voltage, and high voltage goes to this side of the diode. And look at this. This a 3-pin diode for very, very high voltages, and it is configured as a voltage doubler. And this explains why the capacitor was mounted directly to one of the windings of the transformator. So of course, here is a current limiting charge resistor. And the other side, see, this is the center pin, goes via this resistor, and here the other side of the other capacitor and a winding. So yes, a voltage doubler. At least this is my best guess. If we need to know more, we need to consult the schematics. I really like those super cool capacitors. I wonder what they are good for. One more thing that I saw on this PCB. This is, of course, a voltage regulator tube, because it looks a little bit like we got some more signals going in and out of it. But if you look a little bit more careful, there's only two. And it also, if you look really careful inside, there's nothing at all. Just a pin in the middle and a big anode around it. So that means this is full of neon, and I can prove it. See? Yep, here we go. The neon works. See, this is the little oopsie doopsie relay that I talked about with the 3 fuses. They named the fuses really nice and explained how many amps they should be. Fantastic. I haven't understood what is this 357 or .357. That I don't know what it is. But look at this relay. This is really cute. They isolated the base with some plastic spacers and stuff, because this relay, one of the contacts is actually the main part of the relay as well. So of course you need to isolate it. Oh, that is really weird. Why would you do that? It's difficult. Why don't you just take a relay like this in a plastic thing? Just stick it on a PCB and do it right. And why do you need all those relays? Closer look on the rectifier board. Look at all those really cool Motorola diodes. They're just called Motorola 1200, and cathode is the case. That's all was written on them. 2 of them, they've been hot, and there's also a golden one called 1902 something, 0215, and that's also beeps out as a diode. I think I need to save some of those diodes, because sometimes I do repair these old fantastic units that I get, but this one is gonna be scrapped. But I really need to save some of these special parts so I can keep stuff original. But that was the trick to get in here behind all the capacitors. But look at that. Capacitors in sockets. Have you seen that before? Or if I pull real hard. Really? So this is a capacitor in a socket. I can't remember last time I saw this. But yeah, here you go. 3050 volts. I'm of course going to measure this, see if they work, just for fun. But sockets, how cool is that? Here is the motherboard. Actually not that bad. But I see some really dodgy solderings. Maybe somebody tried to repair a loose connection of some sort. You can see this on some of them. And what is that? This is some slimy, gross chemical. Ooh, look at that. Why would somebody spray some stuff here? And if you touch this, you get all slimy on your fingers. So this is really bad. this is the inside of one of the Motorola 1200 diodes. Look at the size of the chip, and it's mounted on both sides with aluminium and then a big copper bendy thing that is then welded to the bottom pin. High peak current like you cannot imagine it. It must be able to do a lot of stuff, this diode. So when you buy another plug-in module with different frequency ranges and capabilities, all you have to do is take out the 3 screws here in the top, and take off the top panel, and then change the scale. So this is the scale that of course must be supplied together with the plug-in module. And it even says here on the back the number for this scale. When you change plug-in module and the scale, obviously you need to trim the 4 trimmers for the 4 different readouts. Then all the scales will read out correct frequencies. This is the unit that just keeps giving all sorts of funny things. The isolation pads under the transistors, that is actually aluminium, but it's anodized. And up here there are marks where they kind of grabbed them and put them into the anodization, and they're really thin. And of course this coating or treatment is not conductive, but because this is really thin, this is a good thermal good contact. Pretty cool. I think this is the first time I saw this anodization, huh? This is the indicator board. You unscrew this screw. See, there's a common wire that is connected to the metal plate. And here we go. Isn't this just classic? I love it. Aren't you just a little bit impressed about the patience and time invested into assembly of this? So this is the connections to the main board, and this the first slot. But just see all those wires in all sorts of colors and fantastic things. Wow. This takes, I don't know how many hours to do, right? Here is the readout scale unit with the 4 dials. And as you see here, we got like a pull system for everything. Somehow it is connected to some stuff in there. And I think maybe it is possible to take out this piece of aluminum without breaking anything. And oh no, so it's still connected to here. So how the heck is it possible to service this or build it? See, it's mounted on that, because I think it could be real fun to see how this is without breaking it. I figured it out. I just took out this front panel, and look at that, brass inserts, I guess. So those are really good bearings. And this front scale you can take off if you're real smart when you're aligning the different indicators. So now this is out as well. Now we can see exactly how this is done. Wow, look at that. With all brass rollers carefully locked in place, and all those wires that goes, and turn this so it's winded up here and all. So that is pretty cool. And then it comes down here and all the way back, and then here, and then out to this. This is just fantastic engineering. But look, all the shafts go directly to the pot meter. So what is the idea behind that one? Because I just don't figure this out. It just spins around. Maybe it's to give a little locking feeling so they don't... Oh, this one goes really like clickety bad feeling, and it has been like this all the time, that one of or two of them was a little bit strange. So I'm gonna think I will try and remove this and see if it goes away. I finally figured this out. Now I've added, see, a little marker here, and now it is all the way to the stop, and see, click, this is the stop, and this is because it touches this piece of plastic, right? So when I go the other way, here, see, now it passes, and then one more go. Ooh, look at that. Now there's some more distance, and I can continue. And every time there will be more and more distance. One step each revolution, because there's one more. This is so cool. So when you go all the way to the other end, yada 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 yada, just click. Then what happens? And now it's the other one. And this is why you got two of them. So stop one end and stop the other end. And now I also know why there isn't a smooth feel when you're turning those. And this is because there is a crack. See? The crack in the plastic actually goes all the way through. So this makes the distance between those two teeth here a little bit too big. And this is why there's a little bit of bad feel. But all right. This unit is like 4 kilos or something. Heavy duty. And see, the thickness of the metal is just amazing. This is not going to fall apart in a mild breeze, I'm telling you. All right, I hope you had a lot of fun and learned to appreciate the time and ingenuity put into making instruments like this.